Your phone is at 5% battery. You plug in the charger, and slowly, energy flows in. But have you ever wondered, what exactly is happening inside the battery? How does it store energy? And how does it release it again? Today, we will explore the chemistry of lithium-ion battery charging and discharging.
Lithium-ion batteries power your phone, laptop, and even electric cars. They work based on movement of lithium ions between two electrodes. There are four main parts: anode, cathode, electrolyte, separator. Let's understand each one.
The anode is usually made of graphite. Graphite stores lithium atoms between its layers. The cathode is made of lithium metal oxide, such as lithium cobalt oxide. Between them is the electrolyte, which allows lithium ions to move, and the separator prevents short circuit but allows ions to pass.
Now let's see what happens when you use your phone. This is called discharging. Lithium atoms in the anode lose electrons. Chemical reaction, lithium gives lithium cation plus 1 electron. These lithium ions move through the electrolyte to the cathode. But electrons cannot pass through electrolyte, so they move through the external circuit. This flow of electrons is electricity. That electricity runs your phone. At the cathode, lithium ions combine with electrons and get stored. Chemical reaction, lithium ion plus electron gives lithium atom. Remember, energy is released in this process.
Now charging. When you plug in the charger, everything reverses. External energy pushes electrons back to the anode. Lithium ions move from cathode back to anode. And chemical reaction? Lithium cation plus 1 electron gives lithium atom. This energy is stored now. Battery becomes charged.
The overall chemical equations. At anode. During discharging, graphite, that is C6, intercalates the electrons of the lithium atoms and makes lithium graphite LiC6. Again, during charging, lithium ions coming back from the cathode becomes lithium atom by taking electrons coming through the external wire. On the other hand, at cathode, during discharging, lithium cobalt oxide gains more lithium cations from anode and intercalates those lithium cations into the oxide lattice. Of course, during charging, the oxide lattice loses lithium ions and those ions go to the anode. Therefore, the overall reaction is reversible, and this reversibility makes lithium-ion battery rechargeable.
A question we often think is that, why lithium is used? Lithium is used because it is light, it gives high voltage, it stores large energy. That is why electric vehicles use lithium batteries. But overcharging is dangerous. Too much lithium movement can damage battery. That is why our phones have protection circuits.
So remember, during discharging, lithium moves from anode to cathode. During charging, lithium moves from cathode to anode, and electron flow gives electricity. This tiny movement powers the modern world. Next time when you charge your phone, remember, you are controlling the movement of lithium ions. And that's all for today. If you enjoyed this video, like, comment, share, and subscribe to The Chemistry Teacher for more amazing chemistry. Thanks for watching.